Welcome back. In Part 2, we focused on how climatology affects flight planning. Now, in Part 3, we'll discuss real-world case studies and how to apply area climatology data in your flight operations. Let's start with a flight from London to New York during winter. You know the North Atlantic is often affected by jet stream activity and occluded fronts. You check seasonal wind patterns and see strong westerlies, so you adjust your route to take advantage of tailwinds. As the flight progresses, you notice cloud layers building ahead and a slight drop in temperature. You cross a frontal boundary, where wind shear and turbulence are common. Thanks to your pre-flight analysis, you prepare for this with an altitude change and turbulence penetration speed. Let's take a flight in the Caribbean, flying from Puerto Rico to Havana. The seasonal charts show high rainfall probability due to the tropical storm season. As you approach, clouds thicken and you anticipate low ceilings and possible thunderstorms. Adjusting the flight plan, you prepare for diversions and alternate airports. In the Middle East, you're flying from Dubai to Kuwait in the summer. Climatology tells you that high temperatures and high-density altitude could affect aircraft performance. You check wind direction and choose to depart in the morning when temperatures are cooler. The climb out of Dubai goes smoothly, but you encounter strong crosswinds near Kuwait. Your alternate planning paid off. Flying from Singapore to Bali, climatology tells you to expect tropical convection. With high humidity and daily thunderstorms, you check radar trends and adjust altitude to avoid the heaviest convective activity. Real-time updates keep you informed about winds aloft and turbulence along the route. Now, imagine a flight from Rio de Janeiro to Buenos Aires in winter. Cold fronts and mountain waves can affect the route, particularly near the Andes. The climatology charts show high turbulence risk and wind shear in the area. You plan for higher altitudes to avoid turbulence near the surface and ensure fuel efficiency. Let's focus on Northern Europe. Flying from Stockholm to Helsinki in autumn, you check seasonal precipitation charts and see high probability for fog and low cloud layers. During your descent, you prepare for a precautionary go-around in case visibility decreases. Thanks to climatology, you planned your alternate routes and fuel accordingly. Heading to East Asia, let's look at a flight from Beijing to Tokyo in spring. The seasonal wind patterns indicate a high likelihood of dust storms coming off the Gobi Desert. You adjust your arrival to avoid low visibility and ensure safe landing conditions. Your briefings ensure the crew is prepared for any unexpected conditions. Let's move to the Southern Hemisphere, flying from Sydney to Auckland. Seasonal charts show frequent low-pressure systems and intense storms in the Tasman Sea. As you approach, you monitor weather radar for developing convective activity and adjust your altitude to avoid the worst parts of the system. In this case, climatology guides your decision to avoid hazardous zones. For Africa, flying from Cape Town to Nairobi, climatology suggests low-level winds and convective activity are likely. You opt for a higher altitude to avoid turbulence and CBS. Your pre-flight preparation, including reviewing satellite imagery, gives you a clearer picture of expected weather and aids in your decision-making. Flying from Los Angeles to San Francisco, climatology helps you prepare for wind shifts along the coastline. You know the sea breeze will kick in around noon, so you choose an earlier departure to avoid gusty crosswinds during landing. In South America, from Buenos Aires to Santiago, climatology tells you the Andes will bring mountain waves and turbulent air. You plan to stay at a higher altitude and brief the crew on potential turbulence zones. As you approach the mountains, real-time weather data helps you navigate through calmer air. Next, a flight from Vancouver to Calgary. The climatology data shows frequent winter snowstorms and low visibility around this time of year. You adjust your arrival timing to avoid low ceilings and plan for a longer holding time in case of poor conditions on the ground. Flying from Mexico City to Lima, climatology warns of high-altitude turbulence due to mountain ranges. You brief for possible wind shear and turbulent air over the Andes. Thanks to seasonal data, you make sure to optimize your route for smoother conditions. Let's finish with a flight from Dubai to Cairo. Here, climatology suggests the Sirocco winds, hot, dry, desert winds, will affect the region. You prepare for reduced visibility and adjust your descent profile to handle the potential effects of these winds. The seasonal wind charts help confirm that the winds will be strongest during late afternoon. As you wrap up these scenarios, we see how area climatology data plays a huge role in decision-making, whether for route planning, fuel calculation, or safe altitude management. With accurate regional forecasts and long-term data, pilots can avoid surprises and increase operational efficiency. In the next episode, we'll shift our focus to remote sensing, the tools and technologies used to gather data on weather conditions in real time, from satellites to radar. See you in Meteorology number 48, Remote Sensing, Part 1.